So in section 8.2, we're going to talk a bit about the structure of the nucleus. Protons and neutrons reside in the nucleus. We collectively call them nucleons. And they make up the nucleus of every atom that exists. Protons have a positive charge. Neutrons have no electric charge. They have nearly the same mass, but neutrons are just a little bit heavier than protons. And if you go back and look at some of the notes from the previous couple of weeks, there's a chart there that compares protons, neutrons, and electrons when we were talking about electricity. And that gives you their charges, but it also gives you their masses. Smaller nuclei will generally have similar numbers of protons and neutrons. Okay, so hydrogen has only one proton. Helium has 2 protons and 2 neutrons. Lithium has 3 protons and 4 neutrons. Okay, in this picture, beryllium has 4 protons and what looks like 5 neutrons. So similar numbers. But when you get to larger nuclei, they generally have many, many more neutrons than protons. And we'll talk about why that is in just a few minutes, or in the next section. So even though there are an infinite number of substances that are possible in the world, they're all made up of elements from the periodic table. Elements are substances that are a single type of atom. If you have just one type of atom, like just hydrogen or just helium, those are called elements. And there are only about 118 elements that are known. And there are even less that are common. Elements are determined by their atomic number, which is just the number of protons that are in the nucleus. And so here you have the periodic table with all 118 elements. And each number that you see here is the atomic number. This is the number of protons that's in the nucleus of each of these atoms. So a nucleus of helium has 2 protons. A nucleus of iron has 26. A nucleus of arsenic has 33. And any atom that has 26 protons in the nucleus is iron. Any atom that has 2 protons in the nucleus is helium. And so the number of protons is what determines the element. It's what determines its name, essentially. But this doesn't account for really everything that we generally see all the time. Because elements can have different numbers of neutrons. For example, most hydrogen nuclei consist of just a single proton all by itself. Some contain a proton and a neutron. We call that deuterium. And some contain a proton and 2 neutrons, which is called tritium. So here the atomic number, which we write with a Z, a capital Z, the atomic number is not enough to account for the differences between these three because of the different numbers of neutrons. We call these different types of elements isotopes. Isotopes have the same number of protons but different numbers of neutrons. So these are all isotopes of hydrogen. These are also hydrogen atoms because they only have 1 proton, but they're just different isotopes of hydrogen because they contain different numbers of neutrons. The sum of all of the nucleons is called the mass number. We write the mass number with an A. And if we use the mass number, we can now see that we can distinguish between the 3 different isotopes. And though there are many, or there are only 118 elements, there are many different isotopes. So I just pulled a piece from the chart of isotopes just for elements from 24 to 41. And you can see, I think this is chromium, has a bunch of different isotopes. Generally, I think the ones that are in white in this picture are the stable isotopes. The others will decay in some way, which we'll talk about in a few sections. To refer to all these different isotopes, we use a nuclide symbol, which includes the mass number, the atomic number, and the chemical symbol. So let's just look at an example. We want to determine the number of neutrons in each of these isotopes. Here we have boron. Okay, boron has 5 protons and a mass number of 11. And so if the mass number is 11 and the protons are 5, to find the number of neutrons, you would just subtract. And we would have 6 neutrons in this case. And we would do the same thing here. To find the number of neutrons in iron 54, we would just do 54 minus 26. And that'll give you 28 neutrons in this isotope of iron.